Okay, what we're going to do here is we're going to look at a recursive algorithm for printing out the elements in the linked list in reverse order. And if we print them in reverse order, they will be printed out in the order in which we entered them in, because things keep getting pushed down the list as we add new things to the head of the list. So I need a public string method. I'm going to call this toString reverse. Okay. Now, I'm going to actually do this, I'm going to need to, because I need to set it up with a square bracket at the beginning and a square bracket at the end. I'm actually going to have to use a helper method here. Let's declare a local variable s. That's going to be the string that we use to return. And then I need to have a copy of the pointer that points to the head of the list. And then I'm going to create a string. S is going to be equal to a left square bracket plus, and then I'm going to call this, whoops, and then I'm going to call reverse p, okay, and that will return the reversed string of the list that p points to. And then on the end of that, I want a right square bracket. Okay. And then when I come back from that, it's possible, whoops, I did not want both of those there. Okay, it's possible when I come back from that that there was nothing on the list. And if there was nothing on the list, then the length of it will be, actually, let's, instead of checking after we come back, let's check before we go. If, let's put it above this, if head is null, then return square brackets with nothing in between, okay? But if it's not, then set a pointer to the head of the list and create a string that reverses it, and then return s, okay? And actually, now what's the deal? Okay, I need to write that method. That's the only problem there. So let's write, and p is a node variable, and I'm going to call it p in here as well. Okay. Now, so this is the recursive part, and that's the part that's always tricky. Whenever you do recursive method, you have to remember that you have to have an if statement in there, and the if statement looks for the trivial case. Okay, now what's the trivial case? The trivial case is if p doesn't point at anything. So if p is null, whoops, then what I want to do is just return an empty string. Okay, now, and you got to spell return right if you want that to work. Okay, now, what is the non-trivial case? The non-trivial case is if I want to return a reversed string, what I have to return is the reverse of everything after p, which is what p.next points to. Okay, so call the function recursively to print out the reverse of everything except the head, and then since the head of the list is supposed to go on the end if we reverse it, then we get back from that, append this, and then plus the element, where'd that come from, plus the element that p points at. Okay, and now if I go back to my main program here, I've already added some lines to reverse it here and here. As I modify it, I print it out both in order from head to tail, and then I also print it out in reversed order from tail to head. So let's run that and just see what we get. I think we're going to have a little mistake in here, but we can probably fix that pretty easily. Yeah. And you see what the mistake is. The mistake is that extra comma and a blank that's going here at the beginning, and it's going to be in every version of it. And so let's go back and look at my linked string list. And when I get back, I put a square bracket on the front and a square bracket on the end. And actually, let's wait on that now that we know we've got a problem. And S equals. Now we know we're going to get something back, because if it was an empty list, we would have returned already. So we know we're going to get at least one item, which means we'll have at least one comma and a space at the beginning. So S is going to equal S dot, and my system is very slow right now, S dot substring, and I want to start at column 2, which would be the third column because it's zero based, and everything from that point on. And then I guess what we can do is we can put square bracket on the front, and we can put a square bracket on the back, and then we can return S. And actually, I could probably combine all three of those statements into one, but sometimes you do that, it gets a little long and a little bit hard to follow, so we'll just leave it the way it is. Now let's run it, and I think we've gotten rid of the extra stuff. So the list in the beginning is Curly, Mo, and Larry. This is the head, this is the tail. If I reverse it, I get Larry, Mo, and Curly. After I remove Curly, I've got Mo and Larry, and reversed it's Larry and Mo. After I remove Mo, I've got Larry, and if I reverse it, it's Larry, and after moving Larry, that's my list, and if I reverse it, I get that. So that's a recursive algorithm for printing out a string in reverse order. You could also rewrite our toString method up here and make it recursive. You'd probably have to do the same thing that we did down here and divide it up into two parts, a non-recursive part and a recursive part, because we're doing this business with the square brackets. Otherwise, it probably wouldn't matter. But it's going to be pretty similar, except if you're printing it out in the correct order instead of the reverse order, then guess what? This part here is going to go at the front. Otherwise, it's pretty much the same algorithm. So you put the element on before you reverse everything else, and whereas in this case, we put the element on after we reverse everything else because we want this to go on the end. And I think I said reverse before, but we're not reversing if you do toString. So you can put it on before you print out everything else, and then it'll print out the items in correct order.